Hello,
Hello, can you hear me?
hello.
Yeah, can you hear me?
Yes, sir, I can hear you.
Okay, fine. So we'll begin the class with chemistry and we'll start off with the chapter on atomic structure. Okay,
Okay.
so that is the first chapter that you have faced difficulties with, right?
Yeah.
Okay, so after the class in the evening, I'll send you a textbook. You need to go through the atomic structure theory from there. It is known as McMurray's And McMurray and Fay are the two authors, and the name of the book is Chemistry. So that
Sir,
book, hmm,
I have a chemistry exam on Monday, like school guy, yeah.
you
So today
can't,
morning,
uh-huh,
so today morning I just went through the NCRT.
right? Okay.
So so should I still go through this?
This is not for school exams, I'm saying. This is for the next 1 year to prepare chemistry.
Acha, okay.
I'm
All
not
right.
telling this for one particular chapter. You have to read this book for all the chapters for concepts. And
Oh,
this
okay,
is
okay.
not for any school exam and all. This is
Okay.
for JEE next year. If you
Hmm.
want to understand all the chapters properly, you need to read the book.
Yes,
For
sir.
your school exam on Monday, you have to do it yourself. Nothing will change in 1 or 2 days, right?
Yeah.
We cannot do magic. We cannot do that today class, tomorrow class, and day after tomorrow school exam is great, right? That can't happen.
Yes, sir.
So उसके बारे में अभी हम लोग सोच नहीं रहे हैं. We are our focus is long term focus कि 1-2 महीने में you should see a big improvement and you should understand many things and things should be better, right?
Uh-huh.
So that is our focus. We are not worrying about Monday's exam. Okay.
Okay.
Okay. So atomic structure we'll start off with. So first of all, do you know the meaning of what is an atom? What is an atom?
It's the smallest. Uh, it's not the smallest.
Hmm.
Like
According to you, what is an atom?
it's made up of protons, neutrons, and electrons.
That's fine. But the question right now is what is it? Can we, what is that thing that we call an atom, right? You
The
started saying something like it's the smallest, but then you stopped saying it. What is the meaning? What are you trying to say?
it's the smallest unit that can exist independently for an element.
So close. So what you can say is it's the smallest part of an element that still retains all the properties of that element. Do you understand what I'm saying?
Yeah.
So for example, if you take a piece of iron or a piece of sodium or whatever and keep taking a smaller and smaller piece of that, right? Ultimately, you start off with a macro amount of sodium and then you keep taking smaller and smaller and smaller pieces of it, right?
Yeah.
Ultimately, you will come down to a really tiny piece of sodium that you can still recognize as sodium. Do you understand what I'm saying?
Yeah.
If you go down further below this, what you will get, you will not be able to say that that is sodium. Okay,
Okay, then I'll break into
right.
protons, neutrons.
So what is happening is the atom is the smallest part of an element that can still be called an element, right? So it's the
Uh-huh.
smallest unit of an element because it has all the properties of that element, right?
Mm.
So basically, if you go down further inside an atom, you know that there are subatomic particles like electrons, protons, and neutrons, right?
Yeah.
Now, electrons and protons and neutrons are the building blocks of all atoms, but they build all atoms, but obviously they will not have properties of like sodium, right?
Yeah.
They build all the atoms. They also build oxygen and carbon and nitrogen atoms, right? They
Mm.
are common for every atom that is in the universe, right?
Yeah.
So what is the question here? The question is that how is the atom of sodium so different that we can recognize it as sodium as opposed to an atom of carbon, right?
Because the number of protons are different.
Sodium atom here and carbon atom here. What is the difference between them? How can we say that this is sodium and this is carbon?
The number of protons and electrons are different.
Right.
That's
So
what I
basically
see.
the subatomic particles that make up the atom are different and that is what decides the properties, right?
Huh.
Right. So what you will learn is that in any atom, what can be said about number of protons and number of electrons?
They're unique in number.
And they are equal, right?
Yeah, they're equal.
Number of protons is always equal to number of electrons, right?
Yeah.
Number of neutrons is not necessarily same as any of this, right? Could be anything,
Because isotopes.
right? So basically, the atom is going to be defined by how many neutrons, protons, and electrons that it has, right?
Yeah.
Now, we have learned that uh, we have started recognizing all the atoms by the number of protons they have. For example, people took all the elements that they found and they arranged it in the order of increasing number of protons. Okay. So, for example, the first element they found with one proton only, right? They called
Yeah.
that element hydrogen. Okay. And when you had two protons, they called that element helium. Do you
Mm.
understand what has been done?
Yeah, you increase the number of protons.
As the number of protons changes, you start calling them different elements, right?
Huh.
Three protons is becoming lithium, four protons is becoming beryllium, five protons is becoming uh,
Boron.
boron, and so on, right? Six is
Mm.
becoming carbon, seven is becoming nitrogen, like that, right?
Huh.
So basically, people decided that this proton number is the basis on which we are calling the elements, right?
Mm.
Correct. Why did they decide that? Why are they saying that these are different elements? Because they found that number of protons is equal to number of electrons, right? So
Yeah.
automatically, when you say one proton, it also has one electron. This has two electrons. This has three electrons, and so on, right?
Yeah.
And actually, people discovered that all the chemical properties of an element are determined by its electronic configuration.
Mm. Yeah.
All the chemical properties of an element are decided by what? Electronic configuration, right?
Yeah.
Do you have a reason for why that is true? Do you understand why?
Um, like when we arrange them in that
Mm-hmm.
uh quantum electronic configuration,
Mm-hmm.
then we see
Try.
that
Mm-hmm.
then we see that if it's half filled, like the shells, then it'll be pretty stable. Then
Mm-hmm.
fully filled will be more stable. And
Right.
then we if there is only like one electron in orbital of another principal quantum
What I'm
shell.
saying is try to use terms that we have not introduced so far. Like right now, I don't know how much you know about the quantum orbitals and all, but try to explain it in words that we have introduced so far only, right? अभी तक तो उसकी बात नहीं हुई ना quantum shells और वो सब की, right?
Acha.
I'm just asking you, how do you, why is that, why is it that All the chemical properties of an element are decided by electronic configuration. That is what I'm asking. Can you think of a good reason, simple enough reason for it? The
Mm,
reason is easy only. If you look at an atom, do you know the comparison in size of the nucleus and the atom?
the nucleus is 10 to the power minus 15
Uh,
meters, and
roughly.
roughly, and atom is 10 to the power minus 10.
Right. So you can see that the atom is much, much bigger than the nucleus, right?
Yeah.
The you can see there is an order of 10 power 5 almost, right? Difference.
Hmm.
So electrons are somewhere outside in the whole atom. You can find the electrons in the whole atom, whereas nucleus is somewhere very close inside, right? And
Yeah.
nucleus has the neutrons and protons, and basically nucleus will become positively charged, right?
Hmm.
And electrons will be going around the atom in different shells and so on, right?
Yeah.
So when two atoms interact, what happens ultimately in 99% of the cases is either electrons go out or electrons come in. Do
Hmm.
you understand what I'm saying?
Yeah. Like
Nobody
covalent.
is touching the nucleus.
Oh,
The,
so the interaction is because of electrons. That's
yes.
why chemical.
All the interactions are only in the outer layer. The electrons either are being lost or gained. That's it. Electrons lost or gained lead to chemical reactions. These are what is called chemical reaction, right?
Yeah.
When oxygen is forming a bond with another oxygen atom to become O2 molecule, it's just the electrons here that get shared, right?
Yeah.
Nobody is touching their nucleus. You understand?
Yeah.
So ultimately, how the electrons are arranged will determine which type of reactions will happen. Do you understand what I'm saying?
Yeah.
If all the reactions only depend on electrons being lost or gained, then the how the electrons are arranged, what are their energy levels, and so on, will decide what kind of reactions they can do, right?
Yeah.
Correct? No.
Hmm.
So therefore, we realize that actually all that matters for chemical reactions is simply the electronic configuration, right?
Yeah.
It doesn't matter how many neutrons or protons are there. What matters is how many electrons are there, what is the energy levels in which they exist, and how those can interact with other atoms, right? The
Yeah.
only place where nucleus comes into play is nuclear reactions and nuclear fission and fusion. Basically, very rare cases like atomic reactors and atom bombs and all, right?
Yeah.
Where the nucleus itself can change. Okay, that is very rare. Do you
Uh,
understand what I'm saying?
yeah. Like.
That is
Okay.
very rare, but it is super important also because that's how the sun is bright. Sun is shining. That's why. Because when the
Yeah.
sun is shining and giving us energy, and now life depends on it, it's because of nuclear fusion happening in there. But that is not something that we are discussing right now. Okay.
Okay.
So what you should understand is that what is the important thing about atoms? It is the electronic configuration of the atoms, right? And that is what decides their reactions and reactive abilities, right?
Yeah.
Now, obviously, if electronic configuration matters, then we automatically know that number of electrons will always matter then, right?
Yeah.
And number of electrons matters means in an atom, number of electrons was equal to number of protons. So therefore, if you have different number of protons, you have different number of electrons. So you will be called a different atom or different element, right?
Yeah.
That's why carbon is different from nitrogen, because carbon had 6 electrons and nitrogen had 5, 7, right?
Yeah.
Do you understand what I'm saying?
Yeah.
The electronic configuration of this element will be different from this element. Therefore, their properties are different, right? And
Yeah.
therefore, when we see an atom of carbon and an atom of nitrogen, we can distinguish between them, right?
Different properties. Yeah.
They have different properties, they have different electronic configurations. That is the reason. That's why they are called different elements, right?
Yeah.
Okay. Now, before we go ahead, you should know, obviously, you already know, I think, the terms atomic number and mass number, right?
Yeah.
Atomic number is what?
Number of photons.
Number of protons, which is obviously going to be same as number of electrons, right?
Yeah.
Mass number is
Num Protons plus neutron.
number of protons plus number of neutrons, right? Okay.
Yeah.
Now, one table that you need to understand is all of these subatomic particles. So, electrons, protons, and neutrons. You need to understand their basic properties like charge, mass, and location. Charge,
Hmm.
mass, location. So, charge of an electron is how much?
1.6 into 10 to the power minus 19 coulombs.
With a negative sign, right?
Yeah.
And for proton, it is same, this, right?
This plus.
And for neutrons, it is zero, right?
Hmm.
Mass of the proton, do you know? Mass of an electron?
9.1 into
Hmm.
10 to the power minus 31 kg.
Right. Okay, so you already know it. Protons and neutrons have roughly similar mass and they are around this value,
Yeah.
right? Roughly same. Neutron is slightly heavier, but we don't care about that much difference. Okay.
Hmm.
We can say that they are roughly equal. But what you need to care about is that notice the difference between this and this, right?
Yeah.
It is
Proton.
almost 5,000 times higher, right? At
Yeah.
least 10,000 or 5,000, like that much bigger, right? So
Ah.
protons and neutrons are much heavier than electrons, right?
Yeah.
This is location is in the orbit around the nucleus, and obviously these two are in the nucleus, right?
Hmm.
Now, you must have heard of the idea of Coulomb's force. Do you know about Coulomb's force?
No. Is it because of electrostatic,
Uh,
like
Coulomb's
difference
force
between?
is the force of attraction or repulsion between two charged particles.
हाँ. अच्छा. हाँ.
You must have
Yeah.
seen it somewhere. Like charges repel and unlike charges attract and so on.
हाँ देखा है.
In atomic structure only, when they would have taught you, they would have told you this, right?
They didn't mention Coulomb's force, but then they told like
Uh,
charges repel.
you have
And
read gravitation in this year's physics.
हाँ.
You know that two masses are there. When they are separated by a distance, they always have an attractive force.
Yeah.
Force of attraction between two masses is what? G m1 m2 by r square, right?
Yeah.
Just like this force of gravitation, you also have a fundamental property of nature that whenever two charges are there like this, they also have a force between them. Okay. And if they are separated by a distance r, the force between them vector is k q1
Q1.
q2 by r square r unit vector. By the way, when you write gravitational force, I would write it like this: minus g m1 m2 by r square r unit vector. Why did I put a minus sign? Let's say
Mm,
this is origin, and let's say this is the r vector, right? And
हाँ then
similarly, this is the origin and this is the r vector, right?
Yeah, so for the gravitation thing,
Mhm.
the force is in the opposite direction as the
Uh,
r vector.
because the force of gravitation is always attractive, okay? So if your r
Hmm.
vector is like this, from this point to this point, the force of gravitation will be pulling it back, right?
Hmm.
Whereas the force of Coulomb force, this is known as Coulomb's law of electrostatics, okay? Notice the nature of the two laws is so similar. Can you see?
Yeah.
It is so similar, right? Here you had m1, m2 by r square. Here you have q1, q2 by r square, right?
Hmm.
The only difference is that here the force is in the same direction as the r vector, and it can be attractive or it can be repulsive. Okay.
So Q1 and Q2 का sign will decide.
Yes. Yes. Q1 and Q2 sign will decide whether it is positive or negative, right? If Q1 and Q2 are both alike, same charges, right? Same type of charge, right?
Then they'll repel.
Then see that the answer will be positive, right?
Huh.
So then the force will be pushing it away in the direction of R, right? And that is repulsive, correct? And
Yeah.
if Q1, Q2 have different types of charges, positive, negative, negative, positive, then it becomes negative, so it will become attractive then,
Yeah.
right?
Hmm.
So you should see the parallel between gravitational force and Coulomb force. Everything that you have learned in gravitational force, gravitational potential, potential energy, things like that in physics, all of it is directly applicable in this chapter also, electrostatics also. So you will learn it in this year, but right now the point is not to do the physics part of it. The point is to understand how Coulomb force works, okay? So if you remember, this G constant in gravitation was 6.67 into 10 power minus 11, right?
Huh.
If you remember in physics, you might have seen this, right?
Huh.
The difference is that the K constant here is 9 into 10 power 9, okay?
It's so much bigger.
So much bigger. So what you will see is, let's calculate the force of gravitation and the force of Coulomb force between two subatomic particles, okay? Do you understand what I'm asking? For example, think of a proton and think of an electron, right? And think of them being separated by the distance similar to a distance if in an atom, right?
Between proton and electron. हाँ, ठीक है.
Think about it. This was, you said, no, this was roughly the radius of the atom, right? So proton is at the nucleus, electron is at this distance, right?
Yeah.
So
So
now let's
then,
calculate the force of Coulomb force first, okay? So it will be K Q1 Q2 by R square, right? So 9
yeah.
into 10 power 9. Notice that Q1 and Q2 are both equal and opposite, right?
Yeah.
So I don't care about the sign right now. I already know it will be attractive force. So attractive force means negative sign should come, right? So I will get Q1, Q2 will be 1.6 into 10 power minus 19 square, right?
Huh.
Divided by R square. So this square, so 10 power minus 20, right?
Hmm.
So roughly, if you think about it, this is going to be 14.4 into 10 to the power minus 38 plus 9. So 10 to the power minus 29 and plus 20, right? So 10 to the power minus 9, right? 1.44 into 10 power minus 8, right?
Yeah.
Do you understand? This is the Coulomb force of attraction between them, right?
Hmm.
Let's now calculate the gravitational force of attraction between them, okay? Because they have masses also, right?
Yeah.
It will be G m1 m2 by r square. That much attraction should be there, right?
Yeah.
So that is 6.67 into 10 power minus 11. And now look at the masses, 1.6 into 10 power minus 27 and 9.1 into 10 power minus 31. divided by 10 power minus 20, right?
Yeah, it's nowhere near that.
So roughly 6.67 into 14.4 into 10 to the power. Now see here, it is minus 7 here, minus 18, minus 49, right?
Yeah.
So can you see the difference in strength of the forces, right?
Yeah.
The Coulomb force is almost 10 to the power 40 times stronger than the gravitation force. Okay. So that tells us that it is electromagnetic forces are so much stronger. We are taking two same particles. No, we did not change the situation. We took one proton, one electron. We took the size near the size of an atom, right? Notice
Yeah.
how much stronger the Coulomb forces are, right? This is an unimaginably big number, right?
Yeah.
That is the difference between them. So that tells us that in nature, all the forces that you see in nature are two types of forces: electromagnetic forces and gravitational forces. And electromagnetic forces are usually much stronger than gravitation. By the way, all the forces that you have ever experienced in life, forces like pushing, pulling, lifting something, all of it is electromagnetic. इवन दो कॉमन सेंस से तो ऐसा लग नहीं रहा है कि कुछ चार्जेस है तुम्हारे पास.
Yes. Hmm.
कॉमन सेंस से तुमको नहीं लगेगा कि यू आर पुटिंग सम फोर्सेस ड्यू टू चार्जेस एंड ऑल. But every force that you have ever done, except gravity, gravity is the only force that you have seen in life which is not electromagnetism.
हाँ, वो खुद से ही हो रहा है.
हाँ, क्या क्या बोल रहे
वो
हो?
खुद खुद से ही हो रहा है, राइट. उसका कुछ.
हाँ, gravity is the different type of force. Other than that, other than gravity, everything else is electromagnetic. For example, I mean, it is difficult to believe it, but I will tell you why. Because you have, suppose you are pushing a wall, right? You are pushing a wall. Now, wall, you will feel a resistance from the wall, or you can push your table right now, you will feel a resistance from the table, right?
हाँ, it's friction, no.
Friction also. Friction is also, I'm going to say, electromagnetic in nature. Everything, even though you might not believe it at first. Friction is also electromagnetic. The reason is this, pay attention. So for example, if you push the wall, you are feeling a resistance force coming from the wall towards you, right?
Yeah.
What is actually going on is that the wall, if you look in an electron microscope, the wall is built of millions of layers of atoms, right?
Yeah.
Millions of layers of atoms like this. And when you are pushing the wall, what you are doing is you are displacing a lot of these layers and forcing them to come closer than they want to be. Do you understand what I'm saying?
But
When
then,
your hand pushes the wall, many of the surface layers of atoms are being pushed and brought closer to the inner layers. Do you understand?
yeah.
Now, why is that happening? Obviously, because you are exerting a force, but this is not cool. This is not cool for those atoms because those atoms have their own electron clouds outside, right?
Yeah.
When two atoms are close by, they want to stay at some optimal distance. This is known as the equilibrium separation or equilibrium distance between two atoms. What is this equilibrium distance? Basically, you should realize that there is attraction between this nucleus and these electrons, right?
Yeah.
But there is repulsion between this electron and this electrons, right?
Yeah.
So basically, if you think of two atoms close to each other, there is one force of attraction between them, between the two nuclei and the two electrons, right? Two electron clouds.
Yeah.
But there is also a force of repulsion between them, between the two electron clouds themselves, right?
Yeah.
So there will come a time when the two forces will get balanced, right? There will come a distance after which both the forces are getting balanced. The attractive force is balanced by the repulsion, right?
Hmm.
Because the forces depend on Q1, Q2 by R square, right? So notice that the location of the charges is different from the location of the nucleus, no? समझ में आ रहा
Of
है मैं क्या बोल रहा हूँ?
the negative charge is different.
हाँ,
Positive.
closer, no? Negative
Closer.
charges are closer to each other, no? So repulsion will be more right now, right?
Oh, so are you saying that the when we push them, the
हाँ,
electrons will come closer?
yes. I'm
So,
saying that only.
acha, and then they'll repel us in a way.
Right. So normally अभी कुछ पुश नहीं कर रहे. Normally दो atoms के बीच में one optimal distance है, right? This is the
हाँ.
optimal distance. This distance is decided based on attractive forces between them being balanced by the repulsive forces between them. Do you understand that there are both kinds of forces?
हाँ.
The nucleus here, A, attracts the electron cloud of B, right?
Yeah.
Similarly, the nucleus B will attract the electron cloud of A, right?
Yeah.
Those are the attractive forces. But what is the repulsive forces? There are two types of repulsive forces. The
Nu
electron clouds will repel each other, both of them,
yeah, and then
and the
nucleus.
nucleus will also repel each other, right?
Hmm.
So the optimal distance is when both the types of forces, attractive and repulsive, are being cancelled perfectly, right?
Yeah.
There must be some distance at which they can remain like this stable, right? But when we push the thing, when we push atoms closer to each other because of our external force, you are pushing them closer than they want to be, right? Do you understand
Yeah.
what I'm saying?
Yeah. Yeah.
And as soon as you push them closer than they want to be, the distance between the charges has atoms has reduced and repulsive forces are now going to dominate.
Hmm. Yeah, I get it.
And therefore, you feel that wall pushing you back, right?
Yeah.
That is the basis, the atomic basis for all of Newton's third law, for example. Why is Newton's third law working? This is why. Because everything is made up of atoms and Coulomb force is happening. When you push something, you got a feeling of being pushed back.
Hmm.
Do you understand?
Yeah.
The reason why I'm telling you all this is because it's important to realize different models of the atom. Different models of the atom were proposed when scientists did not know how the atom works. And in all of these models, it will be important to understand what is holding the atom together, right? So first thing to understand is how is the nucleus held together when there are so many protons in such a tight space, right? Do you understand what I'm saying right now?
Hmm.
It is going to be really difficult to keep so many protons in such a small space close to each other, no?
Because same charge should repel.
They should repel. We just now saw the strength of the force between one proton and one electron, right? We
Yeah.
calculated that and we realized that that was quite a big force. Remember that the force came out to be some 1.4 into 10 power minus 8, right?
Yeah.
And notice the size of the proton and electron is so small, right?
Hmm.
If you have this much force acting on a mass of 1.6 into 10 power minus 27 kg, can you imagine the acceleration?
Yeah. That's be a lot.
It is going to be an immense acceleration, right? If you do
Huh.
F is equal to ma, the acceleration is of the order of 10 to the power 19.
Hmm. Yeah.
So what I'm saying is that the strength of the electrocoulomb force is really huge, right?
Yeah.
They are affecting each other with a strong force. So Now the first question that should come is then how can you, this was even electrons and protons separated by 10 power minus 10 meter. When you put them in a nucleus of the size of 10 power minus 15, the repulsion force should be even more big, no? Between
Yeah.
one proton and another proton, the repulsion should be enormous, right?
Yeah.
Because you are putting them even closer, right?
Mm.
So the first question should be, it doesn't make sense. Nucleus only should be breaking apart, right?
Yeah.
Nucleus should only disperse like this, right? Correct.
Mm.
So why do you think the nucleus is not breaking apart?
Because are the neutrons doing anything?
न्यूट्रॉन में तो कोई चार्ज ही नहीं है, तो इलेक्ट्रोमैग्नेटिक फोर्स तो वो लगा नहीं सकते हैं. Hmm.
Mm.
So this is the point where you have to learn about the third kind of force that you might have seen somewhere briefly. You have forgotten. So two kinds of force we have seen so far are
Oh,
gravitation.
nuclear. Is it because of nuclear force?
So far we have seen these two forces. All of the real life forces that you will see are either this or this, right? And the third and fourth kind of forces, which are hidden mostly for us, is called weak and strong nuclear forces. Okay. Right now, we will not get into the details of why they are two different, weak and strong and all. What you need to realize is these are nuclear forces. They will act only inside the nucleus. Okay. They act only inside the nucleus. They don't act anywhere outside the nucleus of an atom. So therefore, in real life, we will never see them because they only operate inside that 10 power minus 15 meter inside that zone. Okay.
Mm.
And they are stronger than electromagnetic forces.
Even the
They,
weak nuclear forces.
they are stronger. They are stronger than electromagnetic forces because otherwise the nucleus could not be stable. No, nucleus would have broken apart instantly if the electromagnetic forces had their way, right?
Yeah.
But no atom you will see nucleus disintegrating on its own, right?
Mm.
Nucleus is being held together by these forces. These forces are forces between nucleons. Between nucleons. What are nucleons? Nucleons are
Protons and neutrons.
a general term for protons or neutrons, right? So actually, the force between nucleons is independent of whether it is a proton or whether it is a neutron. Both of them are nucleons. Okay.
Huh.
So this nuclear force basically depends only on how many nucleons are there, how many particles are there inside the nucleus, right? So it is similar force between proton proton and neutron neutron. It doesn't care about whether it is a proton or a neutron. You understand?
Is it based on the mass of each? Like because they're similar mass, that's why it doesn't care.
No, it's not based on the mass. It's based on the fundamental substructure of a proton and all. Like every proton, electron and all are made up of things called quarks and all. And there are higher physics things here which decide how the force works. We cannot get into it. Okay. So it's not something that we can discuss right now. Don't worry about how it works.
Okay.
There is a high theory for it, standard model it's called, which also has people, there are doubts about that also. But so far, what we think is the standard model is the correct way to describe it, but it's not our concern right now. Don't worry about it. Okay. But
Mm.
all you need to know is that nuclear forces are pulling the nucleus together and overcoming the electromagnetic repulsion, right? And that's why the nucleus remains stable. Do you understand what I'm saying?
Yeah.
Okay. Now, now we have understood all the different types of forces and how the atoms are stable and all. Now we will go to the different experiments that you might have seen. You might have seen, first of all, Rutherford's scattering experiment.
Yeah, cathode ray. Oh no, no, no. This is the
Uh,
gold foil one.
Scattering experiment.
Gold.
Before that, before Rutherford, there was J.J. Thomson who discovered the atom, who discovered electrons. Thomson's discovery of electrons. So actually, we should put this at number 0. This is 0. Then 1 is Rutherford scattering experiment. Then 2 is
Millikan.
uh, oil drop experiment that you're talking about is to measure the charge of an electron. That is also important. Measure the electronic charge, E by M ratio, right?
Ah,
That is Millikan. We can talk about it briefly. Then there is Bohr's model, because there is problems with the Rutherford experiment.
hmm.
Problems with Rutherford's model. Rutherford's model. And once we do Bohr's model, then we will come to problems with Bohr's model.
Hmm.
Problems with Bohr's model, and then we come to the quantum model of the atom, which is the correct and final understanding that you need to have. Quantum mechanical model of the atom. So that is the sequence in which everywhere you will learn it also. Okay. And that is the historical sequence in which people also discovered things. Okay. So do you know how J.J. Thomson discovered electrons?
Was because of the cathode ray experiment, right?
So what happened there? Tell me.
So there was a glass tube, and
Mm-hmm.
then he evacuated it of all its gas. Like little was left,
Hmm.
but most was taken out.
Let's say it is a vacuum. Then,
It's a vacuum. Then there was a anode and cathode that he
hmm,
connected,
hmm,
and then it was at what high there was high voltage and low
hmm,
pressure,
hmm,
and so the air that was like the little air that was left
hmm,
acted as a conductor,
hmm,
and then because of that, there were these rays he observed
hmm.
from the cathode to the anode,
Right.
and then there was this perforated anode, and behind that he put this fluorescent screen. और फिर
Hmm.
वहाँ पे they saw that there are these particles that are coming and hitting, and then there's like glow.
Okay.
And then he conducted experiments on that with like by putting an electric field and
Hmm.
then magnetic field, and then he observed that they're very similar to negatively charged uh, particles,
Okay.
and that's
So
how.
basically, mostly you're right only. He took any metal he took and he applied a potential difference, right? Using those batteries and all, right?
Hmm.
As soon as he created that potential difference, he started observing that streams of negative particles started coming out, right?
Hmm.
If you applied a high enough potential, then negative particles started coming out of the metal, right? And
Yeah.
whenever he replaced the metal, even if he took a different metal, he still got the same particles, right?
Hmm.
He
Yeah.
repeated this experiment with many different metals, many different things. The voltage required was different, but always the same type of negative charge particles came out, right? So
Yeah.
then he made the next step there and he said that maybe all atoms contain these negatively charged particles, right?
Hmm.
Because they are coming from so many different metals, no? Correct?
They're fundamental.
There must be some fundamental thing because so many different metals are giving the same particles, right? And he started calling these particles as electrons, and these electrons were what were emitted in all of these experiments, right?
Hmm.
Now, once he decided that, okay, maybe all atoms contain electrons, then obviously from there and from the evidence that he had seen, he also figured out that there must be protons.
To keep it stable.
No, because
Yeah.
all the atoms that you usually see are neutral.
Oh, हाँ अच्छा. हाँ.
Normally, you don't see any charged particles, no.
हाँ. हाँ.
Normally, in nature, when you see atoms and all, or bigger amounts of atoms also, it is all electrically neutral usually, right? So,
Yes.
if the metal was electrically neutral and electrons, negatively charged things are coming out, then there must have been positively charged things inside, right?
Yeah.
To keep it all neutral, right? It was looking neutral in the beginning, right?
Yeah.
So, there must be positively charged particles inside the atoms also. Those were called protons, right? They are not being emitted, but they must be there because the overall atom was neutral, right?
Yeah.
Okay, so then he proposed the model of the atom, that the atom must be like positive, negative, interspersed like right?
Plum pudding.
This was known as the plum pudding model, and this was proven to be incorrect by the experiments of Rutherford, right?
Yeah.
So you already know this. I want you to read through this, and this for tomorrow's class. Okay.
Oh, okay.
So I don't want you to worry about quantum mechanical model. I want you to read through Rutherford, Mulliken, Bohr model, and problems with Bohr model. And then we will start trying to understand. We also have to discuss something called atomic spectra and all, which I have not talked about yet. Okay. So atomic spectra and light a little bit. All of this you need to go through. You can go through wherever you have studied it from. NCERT is fine also, right?
Hmm.
And I will send you the McMurray book by the evening. Okay. So you can use that also if you want. You should share your email ID with me. I will send it to you on that email ID. Okay.
Okay, I'll send it in the chat.
हाँ, chat नहीं, WhatsApp पे भेज देंगे, ठीक है?
अच्छा ठीक है.
और go through Rutherford, problems with Rutherford, Bohr, Mulliken's model, then go through Bohr's model and problems with Bohr's model. Okay. And tomorrow we will almost finish all that. So we'll come very close to the quantum mechanical model final. Okay.
ठीक है.
ये सब पढ़ के आओ, and you will realize that as soon as you start understanding things fundamentally, then all of the derivations and stuff will become clear. So we'll do the mathematics of it also. When we do Bohr's model, we'll do mathematically what is Bohr's model, and we'll try to understand it from a very fundamental basis. Okay. So it will not be a problem, but we will take 4, 5 classes, 6 classes total to finish this whole chapter. So ultimately, 1, 2 weeks तो लग जाएगा, लेकिन don't worry about it. Okay.
अच्छा ठीक है.
If you are free, then if you don't have exams and all, we can even do classes during the week. It's not like we have to restrict ourselves to Saturday, Sunday. So
I think this next week we can do it in the week.
one class at least we can do in the week also to get it done faster.
हाँ एक दो तो कर ही सकते हैं क्योंकि मंडे को
हाँ,
मेरा एग्जाम है और फिर नेक्स्ट फ्राइडे को.
हाँ, तो Tuesday या Wednesday we can do at least one class maybe to finish the things faster, but that we can decide. But tomorrow के लिए you know what you have to read up, right?
Yeah, I'll read and come.
Okay, sure. We'll continue from tomorrow then. Okay.
Okay. Thank you, sir.
Bye.